Our third demoer, I'm told, was the youngest engineer ever hired by Bose Corporation out in Framingham. And after that, he decided to go to college at RPI and then at MIT. And the company he started, Holosonics, interestingly, was bootstrapped, no outside funding, entirely bootstrapped from the first customer orders. So please welcome Joseph Pompei.
Hi, everyone. Yeah, I'm going to be talking about the audio spotlight technology. It was really a technology that I had somewhat to describe an unhealthy obsession with when I originally had the idea. I had grown up being a musician and a programmer engineer as a little kid, and as I was growing older, I finally was hired by Bose when I was in high school, and I was being groomed as one of their loudspeaker engineers, worked in a lot of departments, and I learned a lot about the industry while I was there. But one of the most important things that I learned was that what loudspeakers can't ever do. And I really became very fixated on these problems. Loudspeakers, like light bulbs, they're very good at filling rooms with sound, but they give you very little control over the location of that sound or how that sound is distributed. We're used to having that kind of control with light, but we don't get it with sound, and that was missing. And it was something that I thought was important, and because I couldn't convince my bosses that it was important, I was encouraged to, well, go do it. And so I did. So the solution that I had was the audio spotlight. So that you would have a sound that worked like a laser or a spotlight, so that you have the same kind of control over sound that we're used to having with light. So you can control where sound goes, and you can also have multiple sources near each other in a shared environment without interfering with each other and without creating any background noise. So we really preserve the peace and quiet. That really was the ultimate goal of these. So from a technical perspective, the directivity or the narrowness of any wave source, whether it's sound, light, radio, anything, it always depends only on the size of the source compared to the wavelength that it's creating. So normal loudspeakers are, a foot or two big, and the wavelengths that it's creating are more or less the same size, at least that order of magnitude. So you get a fairly omnidirectional pattern, and you also get what are called side lobes, which is energy going out in unintended directions. So there's really no way around that physically. Phased arrays don't work. They can't create any more directivity. So instead, the only thing we can do is use ultrasound. And the ultrasound has very short wavelengths. We're up at the 60, 70 kilohertz range. So the wavelengths are a few millimeters, which is much smaller than the physical device that you see. But of course, you don't hear the ultrasound. It's totally inaudible. So we rely on a property of the air called its nonlinearity. And that causes the ultrasound to convert from ultrasound to audible sound as it travels through the air. So the sound that you hear isn't being created by the speaker. It's being created by this invisible beam of ultrasound in midair that then creates its own sound. So now that audible sound has the directivity properties of the ultrasound instead of what would normally be generated by a loudspeaker. So you get very narrow directivity, 3, 5 degrees, something like that, and no side lobes, just a straight shot beam, just as you would expect from a light. And it really works. Now, this is a very simplified view of this nonlinear interaction, where it might come from. I'll do a little bit of math. If you take two sine waves, you have a nonlinearity, you square it, some weak nonlinearity. You go through a little bit of trig, you get the sum of the frequencies, and more importantly, you get the difference of the frequencies. So if I send 100 kilohertz and 101 kilohertz through a nonlinear medium, among other things, I get 1 kilohertz. And that you can hear. Now, with voice, music, any complex signal, it's far more complicated than this, but this gives you a little bit of an idea of where that sound might come from. So there's two main application areas you can think, themes that we like to think of. One is directed audio. You shine the sound to one location. You provide sound for them, and you don't create a lot of background noise for other people. Or you project the sound, just like shining a flashlight at the wall. Creates a spot of light at the wall. I can shine a spot of sound at the wall and create a loudspeaker at that wall. Very much the same concept. Very unfamiliar, but you can put sound where you want it in all senses of the word. So I'll pause real quick for a demonstration, because everybody's always very eager to actually hear this. Now the speaker panel, it's a centimeter thick. Remember, it's not making any sound wave, it's only making ultrasound. Let me get my level set. Yeah. I'm running it from an iPod. See, I can tell where it's aimed by who's kind of laughing when they hear it. But this is just a simple music track, nothing complex about it. Go a little bit louder than this. Oh, thanks. We can also do sound effects. We can make birds fly around in the room. So there's a bird over in the corner of the room, because I'm just aiming the sound, just like aiming a spotlight. Very much the same thing. You know, we have a usable distance of 100 meters on a quiet day, maybe 200 meters on a quiet night, which incidentally was the distance between the Media Lab building and the river. That's how I measured it. It's as far as I could walk and still hear it. And I'll do one more little demo. This one you have to listen carefully. I'll repeat it 3 times. If there's time, we'll play a little bit more at the end, but I'll get to the... Thanks. This is another technology out of the Media Lab. We're very good at demos. We have a lot of practice. Now, creating the markets, we're also creating the company. You know, this was a technology I brought to MIT. I said, this is what I want to do for my PhD. Nicholas Negroponte, who was running the Media Lab at the time, thought it was an intriguing idea. Went around to a bunch of physicists at MIT and said, you know, what do you think? This kid wants to make this thing called the audio spotlight. You know, is he nuts or what? And in fact, Amar Bose was one of the people he asked about it. And all of them, without exception, especially Amar Bose, said, forget it. The kid doesn't know what he's talking about. This is a purely fanciful idea. It's never going to work. And Nicholas, to his credit, he said, well, this is exactly the kind of student that I want in my lab, so bring him right in. So I have to thank all of those professors for bad-mouthing it. So once I had a working product, you know, basically a working technology, it was still a science project. And I founded Holosonics toward the end of my career at MIT, you know, to really develop this as a real product. And I wanted to do things the opposite of what I saw a lot of my friends doing back in the boom days in the early 2000, 2001 days. I really wanted to focus only on the customers and the real applications and not worry about a lot of investors and what the shareholders think and things like this, and really get, you know, who's going to buy this, how, you know, who's going to make it. So I decided to bootstrap the whole operation, saved $2,000 as a graduate student, paid the lawyer to incorporate, and that was it. Everything else, 100%, has been product sales. No subsidies, no loans, no investors, nothing like that. Now, it does take longer, and you're not making quite the money as fast as you can, but if you can get away with it, you know, it's something that more people, I think, should consider. But in creating this technology, we also had to create the markets. You know, technology like this never existed. It's not like we're coming in with a better loudspeaker. It's a different product for a different application that does not compete with traditional loudspeakers. So we had to create the markets. But what we learned after a few years, and it took us a while to really realize this, is we were not in directional sound business, and we weren't in the sound business at all. We were really in the quiet business, and really what we're providing is surround silence. The person who hears the sound, they don't care if it's coming from an audio spotlight or a regular loudspeaker. It's for the people who don't hear it that the technology is important. So we're really in the quiet business, and the value for those not hearing it was really a theme that carried into our new marketing. It really helped us establish ourselves and really understand really what our market really was. And preserving the quiet was a big part of the theme. One of the big applications that's hot right now is digital signage. This is 7-Eleven, who's using our systems in stores around the world, mostly in the US, but they have a digital signage display, and they originally had loudspeakers. And the loudspeakers were fine for the person listening to it, but everybody else in the store was subjected to these loops, and the clerks especially would object to the kinds of sounds that were being created, and they'd have to listen to it all day. And one of the rules of thumb is, if they can't figure out how to turn the volume down, the clerks, they'll figure out how to turn it off. And if they can't figure out how to turn it off, they'll break it. And that is universal in these places. You can imagine listening to these loops all day. So they replaced it with audio spotlights, and now the only person who hears the sound is the one standing in front of the display and is actually interested in hearing it. And the other people are spared from a lot of the noise that's being created. So you can use advertising more effectively and use sound as an advertising medium more effectively in a shared environment without bothering people. And that's really been a restriction of sound for a long time that's now no longer. One of the most challenging environments for any sound system is a library. You know, who puts a sound system in the middle of a library? New York Public Library had a video wall showing news from around the world, and it was silent. Everybody thought that was kind of silly. And when they found us, they could put audio spotlight systems over each position, so the people who hear the sound are the ones standing in front of the displays, and people reading quietly, they wouldn't have to hear it. Perfect. In a library, and that's the only loudspeaker in the world that's quiet enough for a library to use. And they're still there. Atlanta Airport is using our systems. The ceiling has one tile, I'll outline it in white. That's our system, beaming down to the security queue, instructing people on, please take your laptop out of your bag, please do this, do that, please, do what we tell you to do. As they go through, the person who's standing there pays attention to it. If you have loudspeakers blaring this repeatedly, nobody pays attention to it. But if all of a sudden you walk up and you're about to enter, and all of a sudden you hear a message, you pay much more attention to it. Similarly, on the escalator and walkway warnings, they found that a lot of people would forget they were on an escalator or forget that they were on a walkway, and they want to warn people, hey, wake up, you're about to step off a walkway. They had a lot of accidents there, and they could be very expensive, so they're using our systems as well to warn people at the end of the walkways. Museum of Fine Arts did an installation where they had designers from all around the world do their own themed fashion designs, and they all wanted their own soundtrack, 8 of them in one big room. Impossible to do with loudspeakers, so they used our systems instead. You could see 4 per, because we wanted large areas, much like track lighting, it's track sounding if you like, to create sound zones in front of each of these areas, so everybody would have their own music as they were, as the visitors were standing there, and didn't create any background noise. High Street Salon used our systems as well. They wanted individual LCD screens so that people in their salon could watch television of their choice while getting their haircuts, shave, etc. And they couldn't use loudspeakers in this situation because of the problems with noise that would create and the ruined ambience that would exist. Billboards is another interesting one. Because the sound travels a lot further than loudspeaker sound does for a given amount of level, you can put these on top of roofs. Both of these are New York. The left is in Brooklyn. The right is right in Manhattan. A couple of our systems on the rooftop were beaming sounds down at the people walking by below. On the left, it was just music. Somebody all of a sudden hears music. They say, oh, where's that coming from? And they look up and the billboard is there. So it gets a little bit more attention than they would get normally. The one on the right was kind of fun. It was it was an advertisement for a ghost story. So the marketing company wanted to do something cool. So what happens is, as people were walking by, they hear a whispering voice and say, hey, do you believe in ghosts? And they, but the best reactions, and I stood there and I watched this happen. The best reactions were people walking by, and a couple will walk by, and one of them will turn to the other and say, did you hear that? And they'll say, hear what? And then you got him. I got a lot of hate mail for that one. Now, eventually, we'll get into consumer applications. Right now, we're mostly professional, big installations, stores, museums, libraries, things like that is really our bread and butter these days. Eventually, we're going to get to consumers, and this is just a little prototype I set up in our facility. This is a split-screen TV, and 2 people can sit next to each other on the couch and watch 2 different TV shows and hear 2 different TV shows. Now, of course, you can turn one side off, and one person can read a book, and one person can watch television, 2 different shows, something like that. I use it this way at home. Especially when my girlfriend was in law school, she would be studying all the time. I'd still want to sit with her. I wanted to watch TV. She was reading. I could do that, and she didn't have to hear it. So you can share a physical space without necessarily an acoustic space. Another weird one that just kind of came out was landmine detection. Very unusual. The idea of beaming sound into the ground and reflecting the sound waves and measuring their reflection to image what was below the surface was a compelling idea, and they used our systems to detect so-called invisible landmines, those made of plastic instead of metal, because you couldn't use a metal detector for them. But they do have different acoustic properties than the surrounding soil. So the military is designing detection systems for buried plastic landmines using our systems and laser vibrometer. Certainly a high level of safety. The operator has to be nowhere near there. And it even identifies specific mine models. So it's not deployed, but it is working, and that's where it's going. So in conclusion, this is the basics of the audio spotlight. It's a great technology. It's very exciting. Loudspeakers have been around for 75 years, and I hope that the audio spotlight continues for at least that long. So, pause for questions.
That's great.
Thank you.
I think we have time for one question before we wrap up. And Joe, one question of mine is just roughly, how much does each spotlight cost?
It really depends on the application and the scale. Retail will be in the $1,000 to $2,000 range, wholesale in the few hundred range.